So today we'll be talking about object-oriented programming, right? As you see in our description,
Mhm.
we're now at the end of week 4. So we'll be looking at object-oriented programming. We're going to change totally our way of thinking, what we've
Mhm.
been doing so far. So that will be the primary challenge today, to change the way we've been looking at things and then look at them in a different light. So without much ado, let me jump in to the curriculum and dive into our PowerPoint for today so we can discuss and finally get to the part where we get our practice sessions going. Excellent.
Mhm.
So today we'll be talking about object-oriented programming. It's written in short as OOP, so you see that quite often um,
Mhm.
highlighted. And some of the things we'll approach, we'll try to target our objectives today would be discussing about programming patterns. Now, this is different from design patterns. Design patterns is a whole different picture that we don't need to look at right now. But
Mhm.
we'll talk about the programming patterns that we've seen so far and what we'll see going forward. We'll also look at the two key programming paradigms, right? The
Mhm.
procedural versus object-oriented programming. We'll look at some basics of OOP. We'll look again at constructors, getters, and setters. That's part of the basics. And the principles, the principles of object-oriented programming. That actually goes a step beyond just the basics, but it's good to have these ideas out there. So when you
Mhm.
see them in real life, you can approach them appropriately. So what are we going to look at in terms of big picture? We'll learn how to model problems by using this OOP concept, get to know the basics and some of the principles that guide us to be able to be successful in this. Now, that said, what we've been doing so far, we've looked at data types, right? Variables, how we can get all these data types and put them in data structures, like our collections, which in terms of collections, we're talking about dictionaries and sets. We've
Mhm.
also seen how we can put those in lists or tuples or arrays. Those are sequences, okay? But at the end of the day, we looked at how we can work on our content sequentially, have multiple statements, one line at a time. That's the order in which the program executes. Then we
Mhm.
figured that we can have conditional execution using if-else statements, or we could also have repetitions using while loops or for loops. And finally, we talked about how we can store parts of our program and we use it different areas when we call that execution. So we do have to change our approach from that step-by-step approach into an object-oriented approach. Why do we need that? That's because what we've been doing so far, those are smaller programs, right? That do just a tiny little bit, just a feature or one simple thing. You can code that in 10, 5, 20, 50, 100 lines. But in the real world, when you get into an enterprise or big company industry, you'll be looking at code that is a million lines of code. There's been more than that in areas that I work. So in order for us to be able to easily modify and easily extend this with less code, we have to look at object-oriented programming. Why? Because it models real-world scenarios. We are able to have those large problems broken into smaller pieces, and then we can focus on those smaller pieces. Even in real world, when you have a big problem, you have to break it down into smaller pieces that are solvable. Once you solve all those pieces, you're able to solve the big picture or the big problem. But regardless, programs, the way we look at it, always need to get some kind of input to give us some kind of output. So that's what we're going to use to be able to model that. So let's talk about object-oriented programming itself. So right now in world today, there are two main types of programming approaches. The procedural type, which is centered on procedures, steps, which are more or less functions. You have a function that does something. So you get an input, it gives you an output. That's what has been the driving force of procedural language or procedural programming. Object-oriented programming is centered around objects. So we have a problem we're trying to solve. How do we solve it? We need to take that problem and model it and see what actors we have, what different parts are in that project. So when you do that, you change your approach from the structural, which was first, how structures are set up, to procedural, which is how things were done in the 90s and 80s, to currently the object-oriented approach of object-oriented programming. So like I said, it focuses on objects and real-world scenarios. So for instance, we've been writing this code about rock, paper, scissors. What we are doing is we're trying to look at the input, the program, and then the output. But if we want to look at it in an object-oriented approach, we're going to look at actors. What are some of the actors? The player is the actor. The computer can also be an actor. If you're going to do that, we can decide to have 1 player, 2 players, 3, 5, 10 players. The same with a game of dice, right? So with object-oriented programming, the basic things we need to talk about are the class, okay? So with the class, you're looking at it as a data type. Remember from the onset, we said data has to have a type, string or integer or float and so on. This class is pretty much a type, which in terms of the real-world scenario, we're looking at it as a blueprint. For you to build a house, you have to come up with a blueprint. With that blueprint, you can use it to build one house. If you decide that you like it too much, you build another house. Each one of those houses are different, but they're using the same architecture, or should I say the same template, right? Now, every object in the real world will have attributes, which are known as properties as well. So for instance, this car you see right here has 4 doors. The car has a color. So the type of car, the number of doors, the color of the car, the make, the model, the year, all of those are things that the car has. So what you have is an attribute. What you have is a property, right? In the same light, the class also has a method. The method is pretty much the behavior, how that class is going to behave. For instance, a printer would be a class, right? When you create a printer, it becomes an object. But what does a printer do? It prints. So you can have a behavior or a method to say print, maybe print black and white or print color. If it's a multi-feature printer, maybe you can scan, maybe you can copy. All those will be things that it can do, what it does. So it's an action. The method or behavior is an action, while the attribute or property is a characteristic, something that it has. So finally, once you've had that template, you can use that template to produce an instance of that class. That instance of that class gives you an entity, for instance, an object. But in order for you to be able to create that object, you need a constructor. Constructor is going to help you put all those pieces together, and then you come out with an object. So a constructor would be like an assembly. For instance, if you have plastic, wood, metal, glass, those are all things that you need to put together based on a blueprint, which is a class. That class is going to be using an assembly factory or a constructor to be able to produce an object. So that's just one object. You can produce 10 cars. Okay. So again, as you requested, a class and a type. To explain that, when you start writing code, for instance, you say hello world. The world is of a certain type, a certain data type. That hello is a string. So that data type is a string, which technically is also a class. A string is a class. You can decide to have an instance of a string that's called hello. You can have another instance of a string that's called welcome. You can have another instance of a string that's called hi. All of those strings are created from the class str, that's stir class. So in the same way, we also want to create our own built-in objects. When we said Python is object-oriented, it focuses on objects. That's because all our data types, those primitive data types, those data types that come with Python, integer, string, bool, float, those are all built into Python. In order for us to expand it to build our own type of stuff, we go ahead and create our own objects using a class. We build a class to be our blueprint, and then we can create as many objects as we have. Does that answer your question, Anne?
Yes, so can we say data types they fall under class, right?
Exactly. So let me actually just jump in and show you real quickly. In an example, let's go to the very first class that we did, or day one. So day one, we did a print hello Vitus, right? If we went ahead and checked for, we did not have any assignments in here. Let me go ahead and just create a variable called name, and let's call that name DK, right? If we call that name DK and we ask for the type of that name, it will give us stir. If we went ahead and the type of DK will tell you it is a string. Now, this is what it shows you in Anaconda, or should I say Jupyter. But if I went ahead and looked at what it asks, it shows me in Visual Studio Code. Let's go back to number one. That's Zen of Python. I did import this. Let's look for type of ZK and execute that. Let's clear this first. So if I execute this, it's going to print that, and at the end, oops, I forgot to print it. Good job. I need to print that, and I can probably just cancel this, import this. That way we don't have to look at it and go straight to what we need to look at. Clear this and execute that. You can see here it's actually showing you it's of the class stir. Right, so it's a data type string. That's what we call it in plain English, but it's of a class string. If I had to do print type, and let's try 1, 2, 3, that's going to print the type is from the class integer. Does that make sense now? That's good. Excellent.
Yes.
Good. So let's jump back into our presentation. That's usually a very difficult concept to grasp, but once you understand that, everything else becomes plain. Once you can get around that part of understanding class and type and what the class is made up of, which we'll look at shortly, then you'll be able to understand everything else, because all along, that's what we've been using. We have been importing libraries. Those libraries are extensions of classes that have been built. Each time we write a program, or each time we call it functions, we're actually pulling it probably from an object, which in this case would be a method. So when we look at attributes actually represent, I'm not sure if I have this on the next slide. Let me see. Nope, I don't. Attributes actually represent variables. We talked about variables, right? But this time, those variables are not hanging in the air. The variables are attached or bound to an object. For instance, you have a variable color, but that color is bound to the object car. So we know that if we want to change that car, we change the color. Also, we talked about functions, but functions again are flying out in the air. They're not bound to anything. But methods are bound to your object. You can decide and say you have a method that says drive. That would be bound to the car again. When you say drive, that means the car, or maybe I should say accelerate. When you say accelerate, it means the car should move forward. If you say reverse, it means the car should move backward. If you say brake, the car should brake. So those are things that the car can do. The car can accelerate, it can brake, it can reverse. And those are all methods which you can use and attach it to your car object. Does that make sense? So in a nutshell, that's all we need to know about object-oriented programming. Once you understand these basics, now it's just left for us to be able to write it out, to type it, right? When we practice it, you'll be able to create those. The constructor, again, is, the person that's going to take that blueprint or whatever you call it, the contractor that'll take that blueprint and actually build your house, right? So another way we can look at it is for people that like cooking or baking, you would look at the cake pan or the cookie cutter as the class. Okay. Maybe you have a star shape, maybe you have a round shape, maybe you have a square shape. Those are all different shapes of a baking pan. But then you use that to be able to create your particular type of cake. If you put in a banana mixture, you get banana cake. If you put in a carrot mixture, you get carrot cake. Those are all different types of cakes that you have, okay? But then you can reuse that cookie cutter or reuse the particular cake pan, all right? Excellent. Now let's dive deeper into the principles of object-oriented programming. Now that we've talked about the class as a template for objects, and we know that objects are entities, an instance of the class, which has attributes and methods, we can actually do a lot of things with those, okay? With that, you can actually have some kind of abstraction. When you have an object, you go ahead and hide all the complex details inside the class. And then you only give out the things that are important. For instance, if you're looking at abstraction, it will make it easier for the user to only work with selected behaviors. They don't need to know about all the different attributes. They just need to know what behaviors are out there. Abstraction, again, is like us driving a car. We don't really know how the engine is connected. We don't know all the different things that the engine does. We just know that we put fuel in the car. We step on the gas, the car moves forward. We step on the brakes, the car stops. So all the complexity is hidden in the engine. It just helps us with the simplicity that you turn the wheel, or you turn the steering wheel, the tire turns, the car goes right, and so on. So that's how you abstract all the complexity, and you just give the simplified high-level tool for the users to use your program. With encapsulation, though, it's like hiding your data or hiding your code, but it's also bound together. So again, in this case, it means the information is hidden within the class. Most of the time, you don't want people to have direct access to your attributes because they'll mess things up, okay? You only want to reveal selected information. So when you encapsulate it, for instance, we don't need to always know all the bolts and nuts in the engine or the cables that are passing inside the car for electrical reasons, the circuit and so on. If we need to go ahead and say, fix the headlamps, maybe we'll go to the fuse box and then we disconnect or connect whatever needs to be done. And then the headlights would either be on or off, all right? Now, next is inheritance. Inheritance is easier to understand, I think, because it's just like us inheriting from our parents and our children inheriting from us. Question, Aaron?
Yeah, I'm just trying to understand the difference between abstraction and encapsulation. They just sounded like the same.
Yes, it does sound like the same, but in the next couple slides, I'm going to go more in depth to talk about each one of them with more detailed examples. I think that would definitely help out. It's easy to use this, but also when we start typing out the code, it will make more sense for us to be able to understand, right?
Yes, cool. I'll hold my fire.
Excellent. Thank you. Thank you.
No problem.
So again, inheritance, just like us parents and children or children and parents. When we say our class is made up of attributes and methods, sometimes you might want another class to be created, which is a subset of that main class. Maybe you don't want all the attributes to be inherited, you want only certain attributes. Then that will lead to inheritance. Polymorphism, again, just like we know from biology, you inherit the methods and it helps you to have different forms, right? So in order for me to talk about each of them detailedly, let me start with abstraction, right? So an example of abstraction, or a couple of examples, let's look at an ATM machine. ATM machine has many, many functions, right? But we are going to abstract just the areas that need an input and an output, okay? So as much as we all know, ATM machines are used to withdraw cash, deposit cash, or check balance. But when you go to the ATM machine, it doesn't give you all of that at once. So it just gives you the options to choose. Choose if you want to do this or that. But think behind the scenes, there is a long code. I don't know how many lines of code. You can imagine all those different functions that are in there. You're not exposed to all of those all at once. You're exposed to just pick and choose which areas you can have input or what output you need. The same with smartphones. When you have your smartphone, you can either use it to make a call, send messages, take pictures or videos, download stuff, but all of those are embedded within your smartphone. While it's embedded within your smartphone, you only have certain areas that you can pick and choose from. So you're having that abstraction that helps you hide the information, but then you're able to get to each one individually. So again, abstraction displays only important information, but hides all the implementation that is behind the scenes. Sounds good? I hope that was a little bit clearer for encapsulation or abstraction. Now let's talk about encapsulation. Encapsulation, think about a capsule, right? Within the capsule, you have a mixture of medications. If it's not a mixture of medications, it might be a mixture of components, chemical components. They are all bound together, but they're stored within one capsule. Also think about a large organization. Within a large organization, you might have many different areas in it, right? There are some areas that, how should I say it? There's some areas that are for purchase, production, accounts, sales, and so on and so forth, okay? So what we do here is encapsulation, which usually is just binding data and code together into one unit rather than having all this dispersed. So when you encapsulate, you're looking at all the different things that your object can do, but you encapsulate it within your class. So within that class, you have all those different methods that are bound together, and then you can call on each method when you need stuff to be done, right? But then you're hiding out your properties or your attributes, in other words. All right, so hopefully that clears a little bit more between what encapsulation is and what abstraction is. So encapsulation, binding it all together. Meanwhile, abstraction is hiding the implementation and just showing the simple interface. All right, so let's jump in further into inheritance. With inheritance, we can go about this, create a class, which is a vehicle class. That class will have multiple attributes like color, size, the type of vehicle, but then we can have children, right? We can have classes that are going to inherit from that vehicle class. In that case, you'll be able to create a car, a bus, a plane, a train, all those different, maybe a boat, They are all vehicles, but they have different attributes. They don't always have the same attributes. Rather than having to create separate classes for each one of those, you have one class and then you're inheriting from there to create multiple objects from the same class, right? Or you can have multiple classes inheriting from the same class. Another example would be looking at an animal class. The animal class has unique, or should I say common, attributes like the name of the animal, the sound it makes, the color, the breed, and so on. Those are all going to be embedded within your parent class, which is the animal. But now you can have child or subsets, subclasses that are derived from the animal class. Those subclasses, for instance, a dog, a cow, a cat, pigs, horses, and so on, they are all going to pull certain attributes from your parent class, and they will change some or maybe add some to make it unique for their purposes. And in the same light, we have polymorphism. Polymorphism, maybe a boy would be a good example. As a young man can decide to be a student, a player, and a writer at the same time. All of those are all different ways in which the person can exist, or in other words, different ways in which the ability can be exercised for that particular person. And another example, for instance, is looking at objects of classes. Say people in this case make the same sound, we speak the same way, or we have the same kind of sound coming out, maybe a voice. And when we look at animals, animals have different sounds, right? So that way in which they morph, they change, the way their behavior is portrayed or displayed makes it known as polymorphism. For instance, a cow is going to moo, a sheep is going to baa, and the dog will bark, and so on and so forth. Chicken, or should I say birds, would tweet. And those are all different ways, differences that are displayed based on their methods. So does that explain, does that clarify that part as well?
Can you just one more time, please?
Yep. So for polymorphism again, we're looking at the different ways in which you can actually, let's put it this way. So polymorphism is the ability for that particular entity to exist in many forms, right? So you can make changes. For instance, the boy in a real world example can be a student, can be a player, it can be a writer. So the boy can exist in different ways in different situations. Likewise, in the case of a human being, if we have animals, people have the same sound, but different animals make different sounds. So again, as you can see in the diagram, you have different sounds for different animals that are made. Those are all ways in which a morph or display or change in the way that things are presented for that class or object in case of an instance. Does that help?
Yes.
Excellent, excellent.
Thank you. Yeah, I know. I probably have to sleep over this, but it's a good start.
Yes, this is definitely a step further into object-oriented programming. Those are just principles, the 4 key principles that are seen, but there are many other things that are in there. The main basic thing to remember is just the class, the relationship between the class, the object, and the parts that make up the class, and how they're going to be used to create a constructor, or used by the constructor to create an instance. So we're going to practice some of that in a little bit to see what we have. Sounds good? So let's see here if I can think of an example that I can use. If we can, let me jump into, I think I'm going to, do I want to use Jupyter? Yeah, that's fine. Let's go ahead and use Jupyter Notebooks and create day 8. Rename that. Excellent. So If we try looking at this, for instance, let's create a list of stuff. So with this first code, this is going to create an empty list for us, right? So we created a list of stuff. Let's say, I don't know, what should I have to create a list for? Yeah, stuff is fine. So within that list, we decide that, hey, stuff append. Yeah, I think I should do it in Visual Studio Code so we can actually see all those nice things that happen. Oops, I always do that. All those nice things that happen with using an IDE. So day 8 is a folder. I'm going to start with example PI. Yep. So let me paste that. So yep, we do have stuff. It's now a list. If you put your mouse over it, it tells you stuff is a list. We're going to use all the different methods within the list. When you put a period, you can see those are the different methods within that list. Because a list also is a class, as you can see when I put my mouse over it. It's a built-in mutable sequence. We did say lists were sequences and they can be changed. If no argument is given, the constructor creates a new empty list. So the constructor that we just talked about, that's going to take all those pieces and put them together. The argument must be an iterable if specified. So the argument has to be something you can iterate over, which means it has to be separated by commas, right? So as you can see here, our variable is called stuff. It is from the list class. With that, we are able to see these are all different methods, as you can see, within the class that can be used. So we're going to append, let's say Python. It's an example of something we'll append. We can also go ahead and still append another item in the list, say Java. Those two would add stuff within the list. We can also use another method for list, which is sort. As you can see, sort is a method for a list. If I type it in there, it tells me that is the definition of the method. So the method is going to run through everything. It's going to get a key, set it to none, it reverses it, and so on. And it gives you a definition of what that does. Sort the list in ascending order and return nothing. So remember, we did say lists usually don't return any, or what we do on strings don't return anything. So the reverse flag can be set to sort in descending order if we want to change this to false or rather to true. So that sorts our list for us. If we want to go ahead now and use a function, print is a function that comes built into our Python code or our Python engine. So print the values of a stream. We didn't talk about streams, but stream again has to do with like the handle we talked about yesterday with files. When you pull a file in, when you have an input, the input or output goes through a stream. Okay, so here we want to print stuff. Let's say we want to print just the first item in stuff. What do we need to do? We type in stuff, and then we provide a value, which is going to be the index. So we want to print the first item in stuff. We can also use a different way of printing that same item in stuff. Another way we can do that is say print. If we use stuff, we can use __ get item. So if I use my arrow to go down, it should tell me what this does. It prints the values of a stream or standard output, optional keywords, and blah, 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 blah. So pretty much it's doing the same thing that we did there. So again, since it is function or a method, we go ahead and enter 0. these two lines of code do the same thing. And there are ways you can make it even more verbose by doing print stuff period underscore get item. In this case, we want to enter stuff and 0. So it's taking the list and the index. In this case, it's just taking the index. So you can do it either way. If I print this, it's going to print the same thing twice. Or if I execute it, it will print the same thing twice. 3 times rather. So let me clear this. Execute that. Okay, so get item. Oops, sorry. This doesn't work because I use stuff here and I use stuff here. Instead, I'm supposed to use list. So when I use list, I'm definitely pointing at I want to go back to the list class and use all the different. I should go back and start from scratch actually. So let's go ahead and do list period, and these are all the different methods that you can use for a list. Right? We're going to use the get item, very similar to the previous method, but in this case you can see it's telling you the definition of get item needs you to act on that list, give us a value for the list, and give us the index. Okay, so the value for the list in this case would be stuff. The value for the index is 0. Oh, I should be good. And I made a mistake earlier. So let's execute that. Python, Python, Python. That's the first item in the list. Is everybody clear with that? Does that make sense?
Just to ask, I noticed that when you were doing the first print of it was the square bracket, and then the second one was the curly bracket. That was Visual Studio Code giving that suggestion, right? And you were just doing.
Very good question. This first one on line 6, this is a square bracket. Is that what you mean?
Yes.
Okay, so this is a square bracket because in order for us to use a list and get a particular item or element in a list, we use that square bracket to actually locate the position of the index. But in this second example, we are looking at the object. The object has attributes and methods. We cannot get the attributes directly, so we have to go to the methods. So within a method, if you want to execute a method, you have to use parentheses, just like the print. Print is a method. The print method uses parentheses. As you can see, this is the definition of the print method. So these last two are methods: the get item method for a list and the get item method for stuff. This get item is inherited from the list because a stuff is a list, but a list is a class 2 by itself. Does that make sense?
A bit, I'll understand with time a bit.
Excellent, excellent. Yeah, once you practice it more and more, you'd understand that. So if we want to, let's see if I can make more sense of that. If we want to check the different classes, not the different classes, the different methods within a particular class, we can use dir, right? Remember how we use dir, for str, for a string? Go ahead and print that and then comment all of these out. So if I execute that, where did it go? Forgot to print it out. This is where I like using Jupyter Notebook sometimes because it's going to just understand what I'm doing. So yeah, it doesn't really print it out nicely. So let me switch over to Jupyter Notebook so we can see the output clearly. I'm going to copy all of this over, go back to Jupyter Notebooks and paste it in there. So execute that. And here you can see these are all the different methods that you can use for a string, right? We talked about strings yesterday. You can capitalize strings. You can check if it's a lowercase. You can get the title of a string. You can check if it's an uppercase. You can check what it starts with and so on. In the same way, we can also check what are the methods of stuff. So if we look at dir and stuff, should be able to see, oh, this stuff has all of these methods that we can use: append, clear, copy, count, and so on. The ones with double underscores, we'll talk about them shortly, but those are private, meaning that they're private to that class. Meanwhile, the others are public, which means you can use it anywhere. Anyone can execute that. But in this case, we're looking at stuff. What happens if we check the methods for a list? We check the methods for a list. You can see that it's pretty much the same thing. So the list and stuff are having the same method. Whatever you use for a list, you can use it for stuff. Does that make sense? So that is why
that is because stuff is a list, right?
Exactly. That's because stuff is a list, and that's why we could say print stuff, get this method and use it. But when we went ahead and did it for the list, the method is different. So this would be an example of, say, polymorphism. The method in here takes 2 inputs, and in this case, it takes just 1 input. But we don't need to talk about that now. I just wanted to show you how you'd go about getting those to be done. Sounds good? Excellent, excellent. So again, another example is we can probably write code that will be able to pull information from the internet. Okay. When we do that, let's see if I don't know if I want to do that now because we have very short time before our break. But again, we can have an input that does a bunch of things in our program, like we looked at earlier. Oops, not there. Right here. Like we looked at earlier, a bunch of things in our program, but then we can break that up as well to have certain specific areas. But when we subdivide the problem to specific areas, we can now focus. A team can focus on one area, another team on another, or you can decide to look at 10,000 lines of code, but you don't need to understand 10,000 lines of code when you look at just 5 of them. So when you're looking at just a particular section, you understand based on maybe a UML diagram, a unified modeling language diagram that will explain to you that, okay, this actor is connected to that actor, this object is connected to that object, and you know that, okay, this object does these methods, I'm able to call this method to get this particular piece of data and so on. So that's why we need to have all of these representations. But in a nutshell, understanding these basics, the fundamentals that we've covered in the past week, is what is setting us up to be able to use object-oriented programming to create classes which are blueprints for anyone to go about their business of creating how many objects they need. Okay. So let me see if I can probably run through this in a few minutes before we get back to our break. If we needed to create a class, let me get back into Visual Studio Code. Let's say we needed to create a class. What would be the syntax? The syntax of a class obviously would start with the keyword class. Let me go ahead and say it's customer class. In this case, let me make this bigger. That's good. So customer class should start with the keyword class, and since it is a class, we need to start with a capital letter. Okay, and we want to make sure our classes are nouns. You don't want to just give it a particular a name that is not mnemonic. So if it's a car, you should give it a car which will explain what the actual object is. So in this case, we'll have that class that is created. Now we can go about this by creating particular, say, particular attributes, right? So you would have a name attribute, maybe. You need the name of the customer, you need an address for the customer, and you also need a phone number for the customer. So when you do that, the first thing when you call a class is you have to initialize or use that constructor to create it. So we're going to use def, which is usually used for a function. So we're creating a built-in method called init. As you can see, once I use tab, it just fills everything up for me. So if I put my mouse over there, it tells me it's going to act on the class. Okay, so the pass here is just a placeholder. But since I'm going to act on myself, I can go ahead and use that self and decide what would be the name. Let's say underscore in this case, because I don't want it to be public, I want it to be private, only this class can have access to it. And then I say that should get the name. Right now, I think this is an error because I don't have any input for name. So I need to go ahead and say I will need a name in there. Okay, so we have a name. We also want to be able to get an address, and we also want an input for the phone. So when we create a customer, we'll need to give that customer a name, an address, and a phone number. So now that we've been able to distinguish or to clearly state that this parameter is going to take a variable. Again, think about the variables we created. In this case, our variable is tied to this class, and the variable will be name. Okay. Right now it's saying any because we haven't specified if it's a string or an integer, but that's totally fine. So we also want to go ahead and create our address. And we're going to say that's address, and we also want to do the same for phone number. Say that's phone. There we go. So that would be our constructor. This is how you'd go about creating a constructor. Now that we're done with the constructor, we want to be able to get and set those values. Okay, so we'll need to get the name. We also need to get address, and we also need to get phone number because we don't want to be able to access them directly. In order for us to make changes to these properties or to these attributes, we need to use methods. Okay, so get name method. The same for address and phone. We also want to be able to make changes to those attributes. To make changes to them, we can use a set name. We can also use a set address, and we also need to use a set phone. Those again are all simple to do. So let's start with the get method for the name. So to do that, we'll have to use the definition. Remember, a function hangs in the air, but the method is tied to your particular class in this case. So if we are going to define it, we want to give it a name of the function. Let's call it, sorry, not set. Let's call it get. And the name of the attribute here would be name. We want get name to be able to act on self. Okay, if get name is acting on self, what should it return? Remember, we talked about void functions and fruitful functions. This is a fruitful function. It's going to return something to us. And what we want it to return is that get name. So it's returning the name for us. That's going to be the same thing that we need to do for address and phone. So it's getting the name from here, which is a name that was inputted when we created that object. So when we call that method, it's going to pull that information for us and give us that output. The same thing has to be done for the rest of address and phone number. So you just have to be careful to make sure that you don't do any silly typos. Again, autocomplete will help you out, but I'm being lazy here and doing address, address. And do the same as well for phone. Get the phone and also get the phone here. So now we've created 3 methods. Method to get the name, get the address, and get the phone. That's how we'll be using to accessing this class. The same way we can do it for the set methods. The set method, we're going to, in this case, change the value within that object that is created from this class. So to do that, we're going to need 2 things. We need the name of the object and we need a new name. So we're going to use def again to define what we're doing, set name. And the set name, like I said, is going to take that particular object as well as some kind of name, right? When we get that, we can go ahead and say what, in this case, the self name, see, self.name should now, should now get an assignment, which is that name that has been given to us. So the name that you're going to use and the object is what we're going to go ahead and change it to. In the same light, we're going to do the same for, see, forgot to copy it. We're going to do the same for the address and the phone. Let's call that set address. Here we want address. Oops, that's because I don't have address in here. And in this case, we want to get address. Same here, we want to set the phone. We're going to get the phone input. And we're going to make sure that what needs to be updated is the phone attribute. And we'll update it with the phone. So this is how you'd go about. Oops, I cannot minimize this. Why is it not? Control minus. Yep. So let's see. This is how you go about creating a customer class. So the customer class has your constructor, which is used to construct that object when we call that. We also have, in this case, since we had 3 attributes, we're able to get those attributes using these get methods. These get methods are known as accessors or getters. And then we also went ahead and created 3 methods, which are setters or mutators. That's how we go about creating a constructor, creating getters, and also creating setters. From here, we can go ahead and create as many instances as we want going forward, now that we've finished with the class. So now that we're done with the class, we can go ahead and create instances of that object. Question?
Yeah, can you maybe just simplify what a getter does and what a setter does?
Excellent. So let me go about doing that by creating an object, and then we'll see how we can use that object, right?
Okay.
Does that help?
It does. And if you could, the difference when you're doing your constructor,
Yeah.
the difference between, initializing with self dot attributes and self dot underscore that attribute.
Excellent, excellent. So let me go ahead and add another attribute in here, which will be self dot, let's give it a particular one and say title. And in this case, I'm just going to say president. So we've given another variable which is tied to our class. So in that case, it's a attribute. This attribute is the president. You can always access it without having that double underscore. It means I'm telling the code that it's public. Anybody can access it at any time. Okay.
Okay. When you say anybody, any other subclass or?
Very good question, because normally when you create your class, you want to have all of this code in a single file.
Yeah.
So anyone that does not have access to that folder can still make changes to that file. In this case, can make changes to the title. But if you want to protect that title so that changes are only made from within this class, then you have to use those double underscores.
Okay, and that is the meaning of no, okay, no, you go. I'm getting confused.
You're getting it?
I think I just got a bit confused. I get, so the underscore, the double underscore piece allows for privacy.
Exactly. Make sure that it's private. You cannot access it outside this class. But if you make it public, then you can access it outside the class.
If you inherit that class.
Exactly. Even you inherit it or just calling it.
You cannot, it's still going to behave that way, right?
Yes.
Okay. Okay, cool.
All right. So let's go ahead and try creating a customer. For me to create a customer, I can go ahead and say, let's say customer 1. Let's call it that way. I can spell correctly. That will help. Customer 1 is going to call customer, and then I can pass in, as you can see, it's going to take in a name, can take an address and a phone number. So my first customer would be John Doe. That will be the name of that customer. The address is 123 Main Street. And the phone number is 123 456 7890. Now I've created a customer. I can go ahead and create another customer even. Okay. Let's go ahead and, oh, I forgot what I needed to do. Oh, got it. All right. So this is customer 2. I've duplicated that. Where did it go? And let's call it customer 2. This will be Jane Doe. I couldn't even spell John. Jane Doe lives in that same street, but let's say her number is different, 0987. Now I can go ahead and print customer 1 dot. As you can see, I can definitely print the title of customer 1. All of them will have the same title. I can also go ahead and say get name. If I do that, I'm going to print the name for customer 1. Does that make sense? Everybody good with that? So
yes.
Okay, so customer 1 get name, even though I forgot to put my function. So let's execute this and see what happens. It prints out John Doe. So you can see that if it's too low. I should clear this. It doesn't look nice. So now I can get customer one's name. I go ahead and create this. I can use it anywhere. But if I wanted to get just the name, let's go ahead and print, get access to the name directly. Customer one dot name. Execute that. It gives me an error.
Yeah.
Because
Just again, name. Okay. Okay.
Okay. But I could probably go customer one title. Execute that. It has John Doe and president.
Okay.
Does that make sense? So
Yeah.
I'm able to get title because it's public. I'm not able to get phone, address, and name because it's private. Let me hide this. This keeps printing everything out. So that's how you can hide your attributes. You don't want, for instance, people to change your social security number or change anything directly when they create that object. Once you create the object, you set all those things, and then you can maybe change your title. That's fine. If I want to change the title of customer one, all I have to do now is customer one dot title is equal to, or it should be assigned to, Secretary General. Now, if I run this, customer one title is going to be different. Let's clear this out and execute that. Now, customer one title is Secretary General. I can make changes to it directly. But if I want to make changes to the name for customer two, I have to use get name. Sorry, not get name, set name.
Mm-hmm.
Now, set name takes in a particular name. What name do I want to use? Mary Poppins. And I can go about printing customer two. I already have that down there.
Mm-hmm.
Now I can go about and do in customer two get name. And if I execute that, Mary Poppins is now the new name, and the Secretary General is still the title for number one.
Can you scroll up to your get methods, please?
Yep.
Okay. Okay. Cool.
Looks good.
Yeah.
Well, like I said, all of this is going to be in one file, right? So if you look at, if we go into python.org to try to decipher what is built on, these are the kind of code that you see for the string class, you see it for the list class, you see it for the int class. It's defined in this way. It tells you all the different methods you can do for it. In here, we just have 6 methods that are tied to our 3-4 different attributes.
Mm-hmm.
Question?
Let it sink.
Excellent.
I'm trying to understand. It seems like the set name is used to make changes, and then the get is used to pull information.
Excellent. Excellent. That's it. Yeah. So you can think about any object in this world, whether it's a car or a house or a customer or a player or anything. That's how you go about creating it. You use a class, which will be the blueprint for that. When tomorrow your manager comes to you and says, hey, we need to make changes to this, all you have to do is go in, add what you need to add. If it's an attribute for the class, you build a getter or setter, and then you're fine. You know, maybe you don't need to go back to the parent car. Maybe you already created an animal class and they told you that, hey, in our zoo, we have only a dog and a cat. Now you can go about, you don't want to create multiple classes. You take that dog, that animal class, you go in and change the way that the animal speaks to bark. You change the other one to meow, right? And then you have those. Tomorrow they'll come back and say, hey, we also have a lion, we have a goat, we have a horse. You just go about extending that. Otherwise, it's going to be very difficult for you to go and start writing separate code. How does it all tie in? That's why object-oriented programming is easy for you to make modifications, to make extensions, and so on and so forth. Does that help? Excellent. So that's why I said it will be challenging for us to try to think about it today, since we are changing our perspective completely from procedural to start looking at everything as an object. Everything in Python is an object. So when we go about importing a module, you're importing sometimes a class, and then you're using only particular methods within those classes to use your code. So we'll look at that when we get back from the break. I know we've talked about too much already today, so let me stop here before we proceed and get a quick break so that we can digest what we've covered. So we've talked about abstractions, encapsulation, inheritance, and polymorphism. We're not going to do most of that today, but it's good for you to just have that in the back of your head. If we're going to look at, object-oriented programming in depth, that would be an intermediate level. It's not necessary for the basic level. The basic level is what we've already covered, but we're going to proceed and take a quick break now. And remember that errors should not pass silently unless you explicitly silence them, okay? So in addition to that, in the face of ambiguity, refuse the temptation to guess. There should be one, and preferably one way, which is the obvious way to do it. And although the obvious way is not always obvious at the first, unless you're Dutch. That's actually a joke on Mario von Bossum, the guy that created Python. So he's Dutch, I think. And it's just a joke that he's the only one that's too smart to know the things that you need to know at first, because he's the benevolent, I forgot the full meaning of it, BNF, the benevolent founder of Python. That said, let me escape from this and give ourselves, let's say, 10 minutes break. And then when we get back, we would continue from there. Sounds good? All right, so our 10 minutes starts now. See if I can get some music going.